Hi, everyone. Let's do more with the magician's coin, some more tests. We want to test the claim that the magician's coin is fair at the 0.01 significance level. P is the probability of heads. The claim is that the coin is fair. Is that the null or the alternative? The claim is the null because coin is fair, P equals 0.5. The case of equality always goes with the null. And if the claim is the null, well, everything else is with the alternative. It's a two-tailed test. I'll do this in blue. The alternative tells us what kind of test it is. It's a two-tailed test. The alternative favors both low and high values for P. So we gather sample data, and let's say we get 63 heads in 100 flips. Now just think about that. The null claim says that the coin is fair. You see 63 heads in 100 flips. Well, think about it. So the sample proportion is P hat, 63 out of 100, 0.6300. We verify that normal approximations are appropriate. Both NP and NQ are at least 5, like before. Now the test statistic, well, the key difference is that the new sample proportion is 0.6300, which now pushes the z-score up to 2.60. See, before, when we saw 51 heads in 100 flips, very close to 50%, the z-score was 0.20, which was very close to 0, and we did not reject the null. But take a look at this z test statistic, 2.60. What do you think? Yeah, that sounds pretty unusual. That's our hunch. But let's check, though. We now find the corresponding p-value. Now, it's a two-tailed test, so we have to combine the two areas in the two tails. I'm telling you there's 0.0047 in the left tail and also the right tail. So the two-tail p-value will be twice 0.0047 or 0.0094. All right. Now, well, think about it, 0.0094. Right off the bat, that sounds pretty low, right? That sounds pretty low. It sounds like the null is likely to go. But when we decide whether or not to reject the null, yes, we do reject the null. The p-value is too low. When the p-value is low, the null must go. We do reject the null. But it's pretty close, actually, right? Because alpha is 0.01, it's 1%, and the p-value is just a bit less than 1%. So actually, alpha was very open-minded towards the null. It was like someone who likes David. This judge is very lenient and almost lets David get away with this. But no, 63 heads out of 100, it's just barely too unusual. We reject the null. So is that a strong or weak conclusion? Is that a strong or weak result? We reject the null. If we reject the null, that's strong. That means there is sufficient evidence. What? Well, the null was the claim, so the null is on trial. So we're weighing evidence against that null claim. There is sufficient evidence against the claim. Conclusion? There is sufficient evidence against the claim that the magician's coin is fair. Which makes sense. I mean, if you think about it, 63 heads out of 100, your sense would probably be that, yeah, that's pretty strong evidence against the claim that the coin's fair. Although, again, it was a close call. The 1% was lenient. It almost let 63 heads get away with it. Next up. Here, we're going to test the claim that a magician's coin is biased towards heads. This no longer includes the case of equality. It's going to be the alternative as the claim. The claim will be the alternative hypothesis. A magician's coin is biased towards heads. So if the probability that the coin comes up heads is P, then the alternative claim here is saying that P is greater than 1/2. This indicates a bias towards heads. P is greater than 1/2. It is the claim according to the wording. And since this does not include the case of equality, it's the alternative hypothesis. Now, the null hypothesis, again, we live in a world where either the null or the alternative is true. Technically, the null hypothesis would say that P is less than or equal to 1/2. But again, and you could write that down. You could write that the null says that P is less than or equal to 1/2. But by convention, we normally replace this symbol with just a simple equal sign. Alpha is 0.10, significance level. And it's a right-tailed test because this alternative favors the right tail. It favors higher values for P. Again, P is greater than 1/2. It corresponds to the alternative, not the null, because this does not include the case of equality. The case of equality always goes with the null. The case of equality always goes with the null. This has to be the alternative. All right. Again, it's a right-tailed test because the alternative favors the right tail for P, greater values. Okay, now, finally, we gather the sample data. Remember, you're supposed to do this after the setup. This time, the coin is flipped 100 times and it comes up heads 60 times. 60 out of 100. Our sample proportion, P hat, is 0.6000. Verify that normal approximations are appropriate. NP is at least 5, like before. Again, the only thing that's different from previous examples in this Z test statistic is that we changed that upper left value. It's now 0.6000. The Z test statistic is, look at this, exactly 2.00. Well, it's hard to say. It's right, kind of borderline, right? You may not have a hunch. It really depends on alpha. We now find the corresponding p-value. Okay, this is a right-tailed test. Remember, it's a right-tailed test. The alternative favors the right tail, greater values for p. It's a right-tailed test, so we need a right-tail p-value. And I'll tell you that to the right of z equals 2, it's 0.0228. The right-tail p-value is about 0.0228. So we now decide whether or not to reject the null. Well, what's the threshold? It's alpha. Alpha was 10% here. Alpha is 0.10. The p-value is 0.0228. Is the p-value low or not low? Is it less than alpha or greater than alpha? This is about 2%. This is 10%. The p-value is less than alpha. The p-value is low. The null must go away. We reject the null. And by the way, it was kind of a close call, right? I mean, z equals 2. Well, it really depends on what alpha is, right? Okay, we reject the null. Finally, we write our conclusion relative to the claim. We reject the null. Is that strong or weak? That is strong. There is sufficient evidence. Sufficient evidence of what? What was the claim? The alternative was the claim. So remember, the idea is that the alternative is like the research hypothesis. Can we prove that this drug works? Can we prove H1, the alternative claim? You're weighing evidence for the alternative claim. You're wondering if the drug works for the claim that, the magician's coin is biased towards heads. Remember, the coin came up heads 60 times out of 100. There is sufficient evidence for the claim that the magician's coin is biased towards heads. So the 60 heads, biased enough. Well, the results are biased enough. The sample results are biased enough. So we're concluding that, hey, there's sufficient evidence that, in fact, the coin is biased towards heads. Now, you might be going, well, wait a minute. Here with 60 out of 100, here with 60 out of 100 heads, we rejected the null and said that there was a bias. And it was pretty clear. Here with 63 heads, we just barely rejected the null. In both cases, we rejected the null, but here we just barely rejected the null. Why was it so close here? Well, a couple of things. For one thing, it's a two-tailed test that contributes, but also alpha was very tight. It was only 1%. So sometimes when you look at 60 out of 100, 63 out of 100, it's hard to guess which way it goes. You have to work it out. It's not like 51 heads where you're clearly not going to reject the null, or 99 heads where you clearly are. All right. In our last example, right? Yeah, in our last example, all right. We want to test the claim that a magician's coin is biased towards tails. Biased towards tails. Now, if P is still the probability the coin comes up heads, then if the coin is biased towards tails, that means P is less than 1/2. That's our claim. And because it does not include the case of equality, it goes with the alternative. The null technically says that P is greater than or equal to 1/2, but again, we usually write just equals. Alpha equals 0.05, which is standard. And it's a left tail test because, well, I'll do this in turquoise. It's a left tail test because the alternative favors lower values of P, lesser values of P. So basically, if we reject the null in favor of the alternative, we have to have strong enough evidence that the coin is biased towards tails. We now gather sample data. 60 out of 100 this time. 60 heads out of 100 flips. P hat is 0.6000. Well, wait, hold on, wait. Before we go on computing things, hold on. We got 60 heads out of 100 flips? Wait, the claim is that the coin is biased towards tails, not heads. Is there any way that we're going to reject this null in favor of the alternative? No way. There is no way it's going to happen. You don't have to do any more computation, really. Just from statistical sense, you realize, wait, there's no way I'm going to dump the null in favor of a tail alternative, a tail-favored alternative, when I'm getting more heads. So based on the sample data, there's no evidence for the claim of a bias towards tails. The sample data is running away from the alternative. The sample data is running towards heads. Whereas the alternative, so the sample is running towards more heads, 60 heads out of 100, but the alternative is going in the direction of tails. There's no way dumping the null. There's no way. If anything, there's a bias towards heads. It should be clear at this point, if you use your statistical sense, that the null will not be rejected in favor of the alternative. But if you were to continue working it out, and I may have you work it out in further detail, I could have you work it all out mechanically. Again, verify that the normal approximations work out. Yes, NP and NQ are at least 5. We've seen that many times before. For the Z test statistic, it's the same expression that we had earlier. Again, we have 60 heads out of 100. So the Z score is now, the Z score is still 2.00. But what do we do this time? Let's see. Let's find the corresponding p-value. It's a left-tailed test. Wait, so when I draw 2 on the Z axis here, it's a left-tailed test. I need a left-tailed p-value, which means I get all of this, all of that. And you're going, well, that's kind of ridiculous, right? Yeah, it is. The area here, the probability is 0.9772. That's your left-tailed p-value. This is your p-value. Is there any way whatsoever that p-value is low? Is there any way that p-value is low? There's no way. Again, it makes no sense for your alpha to be 0.5 or higher, right? There's no way that alpha is going to be 0.99. Decide whether or not to reject the null. Let's see. Almost 98% versus 5%. What do you think? Almost 98%. I think that's higher, right? It's not low. The p-value is not low by any reasonable measure for alpha. We do not reject the null. But we should have been able to figure that out early on. There's no way we're rejecting the null in favor of the alternative. So what can we say? If we do not reject the null, is that strong or weak? Is that a strong result or a weak result? That's weak. That's kind of like, not guilty or the thing. We're not sure if it really works. So we do not reject the null. We do not reject the null. It's a weak result. So there's insufficient evidence of what? Okay. What's the claim? We have to ask now, what's the claim? Remember, the beginning of your sentence starts with the decision. Do you reject the null or not? The end of your sentence deals with which is the claim. Here, the alternative was the claim. It depended on the wording of the problem. Here, the alternative was the claim. And we're wondering, can we prove the alternative? Is the research hypothesis. If the claim is the alternative hypothesis, then it's the research hypothesis. Can we prove it? We're weighing evidence for the claim, that yada, yada, yada. So altogether, there is insufficient evidence. There's not enough evidence for or in support of the claim that the magician's coin is biased towards tails, which makes total sense because the sample is biased towards heads. The sample is biased towards heads. But the alternative was pointing towards tails. So there's no evidence. There's insufficient evidence. There's no evidence. It's going in the opposite direction. There is insufficient evidence for the claim that the magician's coin is biased towards tail. It's like asking your friend, so this guy that you're setting me up with, right? Or this gal that you're setting me up with, is this person a terrible, mean person? Is this person a terrible, mean person? Am I going to dislike this person? And this person goes, your friend goes, oh, well, this person saves kitty cats from trees, and he's going to cure coronavirus. And let's see, is he a bad person? Let's see. Well, of course he's not a bad person. Like, well, at least based on that. If the sample's going in the wrong way, you're not going to reject the null in favor of the alternative. All right. If the alternative is a claim. Next up, test for other population parameters.